Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and hi. We are from section 2 group 19. We will present for our group assignment about the Fourier series analysis. First of all, I will introduce my group members. First is me. My name is Muhammad Badrul Amin bin Hamidan with matric number DA20042. Follow up with Muhammad Afiq bin Zabidi, Muhammad Haziq bin Ramlan and Ni Ahmad Amir Hakimi bin Ni Zulkifli. Okay, for the manual calculation will present by Muhammad Afiq bin Zabidi and Ni Ahmad Amir Hakimi bin Ni Zulkifli, and then we'll follow up with the simulation will present by Muhammad Haziq bin Ramlan. Okay, that's all for me. I will pass to my friends to continue our group presentation for this group assignment. Okay, thank you.
Assalamualaikum, my name is Ni Ahmad Amir Hakimi bin Zulkifli. AE2000008, I will explain for manual calculation. So from the circuit, we get the equation VST. For 20, the range for t is 0 to 1, and for value 0, the range of t is 1 to 2. So since the t equal to 2, then the frequency equal to 1 over t. The value of t is equal to 2, then the frequency equal to 0.5 plus. For omega naught, the formula is 2 pi over t. By replacing t into 2, 2 pi over 2 equal to pi. Next, we will calculate A naught. So by replace the value of t with 2 and the frequency equal to 0.5 plus, we will get the answer for A naught equal to 10. Next, for An, we will enter the value for t and omega naught in this equation, and we get the answer equal to 0. For Bn, we will enter the value of t, which is equal to 2, and the value for omega naught equal to pi in this equation. So we get the final answer for Bn equal to 20 over n pi bracket 1 minus negative 1 power of n, and the final answer for n equal to odd is 40 over n pi, and for even is equal to 0. Then for Bt, we will calculate using this formula, and this is the final answer for Bt. And for DC component, for the first thing we'll find is I naught, which is 10 equal to 4 over 4, 4 plus 4, and we get the value for I naught is 1.25 ampere. In KTH harmonic, we can conclude Vs equal to 40 over n pi with 0 angle. So next, we will find the value for C by using 1 over 3 n pi times 80, and L equal to j n pi times 2. Then we will get these two values, negative j0.056 over n pi and 4 plus j2 n pi. So by using these two values, we will calculate by dividing the total of multiplication of these two values and the total of addition in these two values, and we will get the answer like this. Next, we will calculate Z impedance using this formula, which is 4 plus the value we got from the previous calculation, and for the value for Z is 16.112 n pi plus j bracket negative 0.448 plus 8n squared pi squared over 4n pi plus j bracket negative 0.056 plus 2n squared pi squared.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Zabidi and my matric number is AE20203. Now I'm going to continue the presentation for manual calculation. To find the total current, we are using the Ohm's law, which is I equal to Vs over Z, and we get the answer for the total current is equal to 160 n pi plus j bracket negative 2.24 plus 80 n squared pi square over n pi bracket 16.112 n pi plus j bracket negative 0.448 plus 8 n squared pi square. For I naught, we find the value by using the current divider formula, which is I naught equal to R1 over R1 plus R2 I total. We insert all the value into the formula and we get the answer for I naught is negative J2.24 over n pi bracket 16.112 n pi plus j bracket negative 0.448 plus 8 n square pi square. So the IOT will be 1.25 plus 2.24 over pi summation k equal to 1 in sine 2 pi t minus theta n. To find the theta n, we are using the formula 90 degree plus arctangent Bn over An, and we get the answer 90 degree plus arctangent 8n square pi square minus 0.448 over 16.112 n pi. For In, we use the formula 1 over n pi set An square plus Bn square. For I1, we are using the Kirchhoff law, which is I total minus I naught, and we get the answer 160 n pi plus j bracket negative 2.24 plus 80 n square pi square over n pi bracket 16.112 n pi plus j bracket negative 0.448 plus 8 n square pi square. For V1 and V naught, we can find the answer by using the Ohm's law. For V1, we get the answer 3200 n pi plus j 6400 over n pi bracket 16.112 n pi plus j bracket negative 0.448 plus 8 square pi square. For V naught, we get the answer negative 4.48 n pi minus j 8.96 over n pi bracket 16.112 n pi plus j bracket negative 0.448 plus 8 n square pi square. To find the total power, we are using the formula P equal to V source times total current, and the final answer is 6400 n pi plus j bracket negative 89.6 plus 3200 n square pi square over n square pi square bracket 16.112 n pi plus j bracket negative 0.448 plus 8 n square pi square. To find the V naught, we are using the formula Vs minus V naught over 4 equal to V naught over capacitor value plus V naught over inductor value. And the final answer that we get from this formula is V naught equal to 160 plus j 80 n pi over n pi bracket 8 plus j 2.4 n pi minus 0.2 n square pi square. That's all for the manual calculation part. Now I'm going to pass to the next presenter to present the simulation part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azdi Ramlan. My metric number is DE20010. And I will continue with the simulation of our project. So we'll be using, for our simulation, we will be using the BSpice simulation software to get the measurement for the voltage, current, and power for the circuit. So as you can see, this is the circuit that's been constructed in the simulation software. So we just put for both resistor 4 ohm and one capacitor 80 farad and one inductor 2 Henry. And the source that we'll be using is the V pulse, and this is the parameter. We just put all the parameters that we needed for the source. For example, we have the inclusive 0.5 and the secure 23. So to measure the voltage, current, and power from this circuit, we'll be using the probe that will be given in the simulation software. For example, we need to measure the voltage at this node. We just place the probe at here at this node, and we just run the simulation. So before we run the simulation, we need to set a few things. So we just edit the simulation profile. We need to set the run to time at 4 seconds to T stop. and set start stepping data after 0 seconds. So the analysis type we'll be using for the simulation is the time domain transient. So we just click OK. We just run the simulation to get the signal for this voltage at this node. So we just run the simulation, wait about a few seconds to get this. Yeah. Okay. So after we run the circuit, we get the voltage at that node. This is the signal, and this is the signal before the fast Fourier transform. So to change it to the Fourier form, we need to click at this option at the simulation window. Just click the fast Fourier transform option. So we get this signal for the voltage at that node. So to see in more detail, we just change the axis setting, which is it to 10 Hz to get more detail at the measurement. So this is the example for the voltage at that node 1. Let's say. So this is the example. There are multiple traces that we can see. So for example, we can delete these traces and see for other measurement also. We can see for example, for the first one is we need to measure the current. So we can see here we have the current at IC1. We can see here this is the current after the fast Fourier transform for the capacitor, and the current for the inductor. You can see also. So this is the current for the inductor, and see for the current at the IR1, and also you can see for current I2 for the resistance 2 after the fast Fourier transform. This is the signal for the resistor. So also we can see from these traces, we can see also for the voltage for the let's say we need to see for the VIR2. So we can see here this is the voltage that after the fast Fourier transform. This is the voltage that we obtain from this signal. So this is for example the voltage for V1 CR1. So let's see for the V1 V1 R2 R2. You can see this is the signal that we obtain, and to test for the voltage, but we can be go a bit later. We've been comparing for the manual calculation and the simulation. So for the power is go to the here with W. You can see here, and this is the current the power for the circuit that we can obtain from the simulation. So let's say we have the total current, the total power here. So we have the multiple for the power for C1, L1, R1. You can see here, just for all here. You can see here, this is the power for both for all power that we measured. So next, I will be comparing with the manual calculation that we obtained previously and with the simulation that we obtained in the simulation software. So this is the comparing table that we made to compare the final answer that we obtained from the manual calculation and with the specified simulation. So for the first one, we did for the current R1 I1, the final answer that we obtained from the manual calculation is this answer, and for our piecewise simulation, we get this signal from I1. So for I out, so the I out for the from the nodal analysis that we obtain, we get the final answer, which is here, and the signal for the IOUT that we obtain from the piecewise simulation software that we get here. This is the signal, so we can see from the little bit detail. You see, this is the signal that we obtain for the IOUT. For the V1, from the manual calculation we get this answer, and from our piecewise simulation we get this signal, which is we can go a little bit detail here. See. So from this piecewise simulation software, we get this signal for the V1. So next is for V out. You can see here for V out from our manual calculation, we get this answer for the final answer for V out. After we using some method which is the nodal analysis to get the V out and the nodes. So the voltage for the nodes that we get from our piecewise simulation software, we get here the signal that we obtain from our simulation. So lastly is the power. So by using formula and manual calculation, for the power we get the final answer for the power, which is here. You can see in the table, and from our piecewise simulation at the power traces, we get this signal for the output power for our circuit. So that's it for our group, and for comparing the manual calculation and piecewise simulation. And that's all for me.